Here we go, second to the last set of notes. This is section 11.3 from the textbook. We are on volume, and we are going to look at pyramids and cones today. So let's start with the pyramid. I'll do a square pyramid. Okay. For volume, remember a prism was the area of the base times the height of the prism. For pyramids, it's very similar. It's the area of the base, well, it's 1/3 multiplied by the area of the base multiplied by the height of the pyramid. And remember, height of the pyramid is not the slant height up the side of it, but it's from the tip, the vertex, straight down the middle, like you took a drill and went right down to the center of the base. That's the height we need. So the volume formula is 1/3 big B H. So on my little formula sheet, 1/3 big B H, or you can do big B times H and then divide by 3. Same thing. Cone, very, very similar. Cone is also 1/3 area of the base times by height. But the base, since it's always a circle on a cone, we can replace that with pi r squared. So volume is 1/3 pi r squared H. So again, our height is straight down the middle, making a right angle with the base. And remember, slant height is this diagonal height here, or length, not height. Okay, and that 1/3 pi r squared H. Now we'll do some examples. Let's start with a cone laying on its side. We got an edge of 20, diameter 18, and we are finding volume only. So volume, 1/3 pi r squared H. So we need the radius and the height. Well, the radius, if I look back, easy enough. I'm going to cut the 18 in half. The height is missing, but you've got good old Pythagoras to help us out. Call that H, so we'll do Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. And just doing all of the work on the calculator, I'll go 20 squared, subtract 9 squared, and then square root that. That's the 3 algebra steps that I would be doing there. So the height is 17.86, and now it's 1/3 pi 9 squared times 17.86. So let's go 81 times 17.86 times pi, divide by 3, 1514.94. Okay. Let's try a pyramid. Number 2. Let's make it a trapezoidal pyramid. Remember the trapezoid? We haven't done that in a while. And we have this hidden line all the way back here. So our base is a trapezoid. And here's what we know. 5, 5, 5, a nice isosceles trapezoid. And we've got 4 going across there from front to back. And I want the top to bottom. I'll just do it off to the side here so I don't throw another line in there. That top, that's representing the height straight down to the middle, is going to be 8. So, it's a pyramid. Comes to a point, triangular faces, so the volume is 1/3 big B times h, height being 8. Big B is the area of the base. That's a trapezoid. We have not done a trapezoid in a really long time. So let me look back at the sheet. So in place of big B, we're going to put in the area of the trapezoid, which is base 1 plus base 2 times by the height and divide by 2. So all of that is big B, and then we're going to times by another h. Now, these two h's are not the same. This one is only looking at the trapezoid on the bottom. This is the height of the pyramid. So don't think when you see the same letter that it's representing the same value. It may not be on these three-dimensional figures. All right, so I got this one. This is an 8. The height of the trapezoid, that's how far apart the bases are. Remember, that's 4. 1/3. Do I know both bases on my trapezoid? I see a 5. What I don't have is that dotted line across the back. But this one's a little bit challenging. If you chunk this up, I'm going to draw this trapezoid down here. This is what we're looking at. 5, 5, and 5. I need to figure this out. Well, what I can do is chunk this up. If I go perpendicular from that vertex, I know that's 4. Same thing here. I know that's 4. These two triangles are the same. Congruent triangles. I know this middle piece here is 5. I just need to find one of these, and I'll have the same thing over here. Well, if you look, we can do Pythagorean theorem, or know that the most common right triangle is the 3, 4, 5 right triangle. When 5 is on the hypotenuse, and you have a 3 or a 4, the 3, 4, 5. So this is going to come out being 3 and 3. If not, you could, if you didn't remember that, and you may not have, you could have done x squared plus 4 squared equals 5 squared. 25 minus 16 is 9. Square root of 9 is 3. In any case, our second base is 5 plus 6 for 11. Okay, and now this is a big old calculator problem. So this time I'll do the 1/3. 1 divided by 3 times, that's going to be 16 times 4. I'm going to get that. Divide by 2 times by 8. 85 and 1/3. If I want to go exact. Okay, let me challenge you with this next one. Cone. The circumference of the cone is 25 pi. The height is 2 more than the radius. Find its volume. So, 1/3 pi r squared h. I didn't give you either one of these. You've got to do some work to get them. So we are obviously going to be finding that radius by working backwards from circumference. Remember, to get circumference, it's pi times diameter. Well, if we divide by pi, the diameter is 25, which makes the radius 12.5. That was easy. Now the height is 2 more than the radius. That means the height, we're just going to add 2 to that and get 14.5. Not too bad. 1/3 pi 12.5 squared times 14.5 squared. So, let's see, 12.5 squared times, oops, not squared, see. So if you guys were here, you'd have caught that right away. Times 14.5. Divide by 3. Oh, I'm going to stick the pi in there. Times by pi. 2372.56. And one last example. Oh, two last examples. Two more. Number 4. We have a composite figure. We're going to have a cone, cylinder, another cone, and ask you to find the total volume. And here's what we know. We'll have 21 here, 45 here. We're going to go with this one to the bottom of the cylinder. That's going to be 70. And then this one, even with that, is going to be 40. So, our plan for total volume and nothing in here says that these two cones have to be the same, so we're going to double check everything. So our volume formula is going to be the volume of a cone plus the volume of another cone plus the volume of a cylinder. Now the formula, looking back on the sheet, cone is 1/3 pi r squared h, another cone. And then the cylinder is pi r squared h. So let's do the top cone first. I see the radius is 21. And the height, we got to do a little bit of work. If those two pieces are 70 and the cylinder is 45, that's going to leave 25 up here. That's 6, yep. So we got a height of 25. Now the bottom cone, definitely not congruent. The radius is 21 though, because that cylinder doesn't grow. 21 squared. The height here was given as 40, even though my picture's really bad. And now we're picking up the cylinder in the middle. That's pi times that same radius squared. And the height of the cylinder portion is 45. So adding the three pieces together, let's see what we get. Something very big. So I'll start here. 21 squared times 25, divide by 3, 3,600. I did not multiply the pi in, so I'm going to put it on there. Here, 21 squared times 40, and again divide by 3, 5880 pi. Here, 21 squared times 45, 19,845 pi. So, add 5880, 3675, 29,400 pi. Alright, last one, a little algebra, a little working backwards. Here we go. We're going to find the radius of a cone with volume equal to 15 pi and has a height equal to 5. So, this is work backwards at its best. Start with the formula, then use substitution, then algebra to work backwards. So formula first, volume of a cone. 1/3 pi r squared h. We know the volume, we can substitute in 15 pi for the v. and we have the height being 5. And now it's algebra working backwards. So we want to get rid of the 1/3, get rid of the pi, get rid of the 5, and it doesn't matter where you start because that's all multiplied together there. I am first going to get rid of the pi by dividing by pi. Those are gone. That leaves 15. I can divide by 5, get rid of the 5. That'll leave 3. To get rid of the 1/3, we can divide by 1/3 or multiply by its reciprocal. I'm going to times by 3 on both sides. That will cancel that. That will give me 9. And now I just have to unsquare, and you remember that is square root. So the radius would be 3 to make that volume come out with that height of 5. Okay, that finishes up volume of cones and pyramids.